Now let's look at this differential equation. And here we apply the main definition to see if this is a homogeneous equation or not. So let me take you to that page again. Mm, okay, so the basic definition of a homogeneous equation was an equation which could be where the derivative could be written as a function of y over x. So here we are not having x, but we are having theta. So x is just replaced by theta. So you have dy over d theta. Here the main thing to see is, can every term be written as a function of theta and of y over theta? And the answer is yes. So this one we already have y over theta. Now apparently we have some violation going on because this is not a function of y over theta. This is only of theta. And similarly, this is only of y, and this is only of theta. However, if we divide the numerator and denominator by theta, which we can do, we can always divide the numerator and the denominator of a fraction by the same thing. So when we divide this term by theta, this theta goes away. When we divide this this term by theta, it becomes 8y over theta. And when we divide the 8 theta by theta, we just get 8. So now you see every term is a function of y over theta. We just have y over theta, no other variable, y over theta, no other variable. And remember we said that as long as we just have a constant, that's fine, because it can be written as 8 times y over theta power 0. So any constant doesn't disturb the fact that it's a function of y over theta. So now the second thing is that after that, we knew that to solve it, we have to substitute. There I told you in case of dy over dx, we were doing y is equal to vx. So here you would do y is equal to v theta. V theta. And then after that, the next step was, we go back to that page. The next step was that the dy became v dx plus x dv. And then we do these substitutions in the given equation and turn it into a separable equation. So this is the convenient form, the dy is equal to v dx plus x dv, if the equation is given in the form mdx plus ndy is equal to 0, which is what the form was for the example that we did last time we did this one. So that's given in the form mdx plus ndy is equal to 0. So you substitute y is equal to vx, and where you have dy, you substitute this v dx plus x dv. But when the equation is given in this form, dy over dx is equal to fy over x, then actually it's helpful if from this equation you calculate dy over dx. Dy over dx. So think of dividing all of it by dx. So although that's not mathematically the case, but it works as far as getting the correct formula is concerned. So divide every term by dx. So when v dx is divided by dx, you just get v. And when x dv is divided by dx, you get x dv by dx. So x dv by dx. So this is, it's more convenient to use this last box thing instead of this one when the equation is given in this form, which is what the case is for the problem that we are doing. So remember, dy over dx is equal to, let's even copy it, v plus x dv over dx. Dy over dx. Although in this case we don't have x, but we have theta. So this will be theta. For some reason, this print is coming small. Okay. So here, that's what we will do. Dy over d theta will be replaced with v plus theta dv by d theta. Equals, you can even look at this one because this is more simplified. So I've replaced dy over d theta by v plus theta dv over d theta, and here it will be 9. So the y over theta from this equation, y over theta will be v. So we'll have 9 secant v. Let's copy it. So the y over theta will be replaced by v. And here also the y over theta will be replaced by v. Okay. So now the next step of simplification would be to subtract v from both sides. So subtract this v on the other side. And you see, when you write this v as 8v over v, so this negative 8v over 8, so this negative 8v over 8 cancels with this 8v over 8, and you will get this one will cancel out, and this one will be canceled out with this term. So that's what we are going to get when you do the common denominator here. All right, so now let's put it in the separable form, so that we have a dv on the left, so bring the v terms on the left. So we will have dv over secant v. So dv divided by secant v. And then take the theta terms on the right. So you have a 9. It doesn't matter where the 9 and the 8 are, so I'm just leaving them where they are. So 9, and then the d theta goes up. And then on the bottom you have an 8, and this theta also comes down, 8 theta. Okay, so let's see, we have everything. 9 over 8, this theta has come down, this secant v has gone here. So now apparently this looks a very difficult integral, the dv over secant theta, but remember 1 over secant is cosine. So this is just cosine v dv. This dv over secant v is just cosine v dv. And now you integrate both sides. Integrate both sides. And the integral of cosine v is sine v. This is a 1 over theta, so the 9 over 8 is a constant. So 9 over 8. And the integral of 1 over theta is ln of theta. Plus c. And we saw last time that they have just a c on the right side, so they bring everything on the left. When you do that. And also remember that v was actually, from here, v is y over theta. So this one will be written as sine of y over theta is equal to 9. So the 9 over 8 ln theta should be brought to the left, minus is equal to c. Okay. So sine y over theta minus 9 over 8 ln theta. Oh, here they are making us write in this form y is equal to. All right, so let's change it then. So we should have left that one over there is equal to. So basically they're asking us to solve this one for y. So when you solve this for y, you first take the inverse sine of both sides. And you will get y over theta will be the inverse sine of all the right hand side. So sine inverse of all this. Okay. And then in the next step, you solve for y. And that means you multiply by theta on both sides. So y will be equal to theta. Theta sine inverse 9 over 8 ln theta plus c. So let's see, I've never written sine inverse before in the software. So theta sine inverse 9 over 8. Sine inverse. And then nine over 8 ln theta plus c. 9 over 8 ln theta plus c. Theta plus c. Okay. And here Um, okay, maybe we'll do it in the next segment.